In this video, we're going to talk about definitions: oxidation, reduction, reducing agent, and oxidizing agent. I tell people to memorize Leo the lion goes grr. Loses electrons means oxidation. Gains electrons means reduction. Another way, think about it, if it loses electrons, it becomes more positive. So when something is oxidized, it becomes positive. If it is reduced, it becomes more negative. And we'll do a couple reactions here. Copper plus 2 goes to copper plus 1. We want to know if that's oxidized or reduced, and that's clearly a reduction process because it became more negative. It gained an electron. To balance it, I would write plus an electron. Here's another one. F2 goes to 2F minus, and that clearly is another reduction because it became more negative. It gained electrons. I'd have to add 2 electrons on. Now we'll look at something like this, a little more complicated. 2iO4 minus plus 16H plus yields I2 plus 8H2O. Okay, now we got to figure out what's being reduced and oxidized, so you got to do your oxidation numbers. Oxygen over here is minus 2, hydrogen is plus 1, iodine is 0, hydrogen is plus 1 here, oxygen is minus 2, and iodine here, let's see, that would be minus 8 total, so it's got to be plus 7. Hopefully you can figure that out, see what I did. If not, go through how to determine oxidation numbers. So when I look at this, the iodine in IO4 minus is the only one. It's going from plus 7 over here to 0 here. Everything else stays the same. The hydrogen is plus 1 and plus 1, and the oxygen is minus 2 and minus 2. So it's going from plus 7 to 0. Guess what? It gained electrons. So that must be a reduction. It became more negative. Okay. I haven't given you an example of an oxidation. We'll do one right now. Mn plus 2 goes to Mn goes to Mn plus 2. This became more positive. That means it lost electrons, so I'd put 2 electrons here to balance, and this is an oxidation. Okay? So that's it for there. You can determine some of these if you want. I'm going to give you some balanced reactions, and we'll determine oxidation, reduction, and then we'll define oxidizing agent and reducing agent. So let's determine in this reaction which are reduced and which are oxidized. This is going to be a little more difficult. One trick is ignore the hydrogens and oxygens. Check them first. The second trick is, for us, we're only going to find one element reduced and one element oxidized. So I'll check the bromine. The oxidation state of bromine here is minus 1. And on this side, it's an element, and it's 0. And then I'll check the Mn. Mn is plus 2 over here. And let's see, oxygen is minus 2, so there's 4 of them. That's minus 8 total. That's minus 1, so this must be plus 7. Manganese is plus 7. So when I look at this, bromine went from minus 1 to 0. So I have Br minus going to Br2. I'm not even trying to balance it. It's going from minus to, and I can try to balance it a little bit. I'm going from minus 1 to 0. So that means, did it gain or lose electrons? It loses electrons. And Leo goes grr, so this is oxidized. It became more positive. And then that, hopefully, that makes our manganese reduced. And clearly, manganese O4 minus going to Mn plus 2, going from plus 2 to plus 7, it's clearly gaining electrons. So gains gains electrons, so it is reduced. And that's how you do this. Now, the oxidizing agent and the reducing agent. The reducing agent is the thing that caused MnO4 to become reduced, so it is the Br minus. The Br minus is said to be the reducing agent. Notice it's exactly opposite of what happened to the bromine. The bromide become oxidized. It lost electrons. The manganese gained electrons and was reduced, and it causes the bromine to be oxidized. So the MnO4 is said to be the oxidizing agent. So the easiest thing to do, and this is how I do it, I figured out what's reduced and what's oxidized, and then I know it's opposite for them. For the thing that's oxidized is always the reducing agent. The thing that's reduced is always the oxidizing agent. And that's how I work that out. Let's do one more. Okay, here it is. And as always, we'll ignore the hydrogen and oxygen to last. If we find something before that, we're good to go. So we'll look at the chromium. Chromium here, we'll look at the oxidation state. Oxygen's -2, and there's 7 of them. So it's -14. It's -2, so that's a -12, because I need a +12 on this side to add up to -2, so chromium must be +6. And over here on this side it's +3, so chromium Cr2O7 -2 is, let's see, it gained electrons, so it was reduced. Therefore, it is an oxidizing agent. And now we look at this. Oh, this is tricky. I got oxygen is -2, that's -6. Arsenic is +1. There's +3 on this side because there's 3 of them, and 3 of these. That makes the arsenic here, I'll put it in red, +3. And on this side, I have arsenic -8 for the oxygen, and I got again +3 total for the hydrogen, and so the arsenic must be +5 because it got to add up to 0. Okay, so there we go. I found the other one. H3ASO3 goes from +3 to +5, so it lost electrons and it was oxidized, which makes it the reducing agent. There you have it.